Okay, where was I? What was I up to? So next step, rip out 1024 from priority queue and other hard-coded capacity like free list dependence on order type. Yes, indeed. This is very important. We should. Shit. Where's my water? There we go. Ew, what the fuck? This water bottle is dirty as hell. What the fuck? How did this happen? What the hell? Weird ass water bottle. Get a different one. Okay. So priority queues are fixed to size 1024 right now, which is really not ideal. We want them to. I guess we could make them double as they need to grow. So let's do this. Let's see. Nothing to commit. VI. Let's modify the this guy, and on this side we'll modify the header. Actually, let me do this. Pull up OBS again. Just move my face down a bit so you can. No, fuck it. I have so many things open here. Why do I have so many things open? It doesn't seem right. Oh. Shit. There we go. Make sure the YouTube is actually working, because it just doesn't sometimes. Okay, it's working. We definitely do need a PQ in it, but we don't need the capacity anymore. So capacity will kind of be, it'll start at 1024 and then it will grow with us. We'll grow together with the priority queue, and we've already figured out where to put this. So VI. All right, let's just focus on the .c. So capacity is passed in here, but we don't actually want it to be passed in anymore, so we'll do that. So, I mean, we could do something like, what is it? Cat include, I think schedule has a bunch of, static const uint. I think this has to be a 64 type. Yeah, 64. Initial capacity is equal to 1024. The initial capacity can be 1024, that's fine. And then we're basically going to do initial capacity, and there we have it. and you too. Yeah, and this is just where we save capacity, just to save an extra space. This is one. Don't question. Okay, so when would we need to double? We only need to double when do we need to double? When we push. Peak and pop wouldn't change it, so it's just here that we need to double. Oh my god, my head today is foggy. While one. That doesn't make any sense. What the hell? We need to double it and then we can insert it. So this should actually be very similar to the other doubling code that we have in bullshit, maybe? Oh, someone has it open. Perfect. Who has it open? No. Wait, I wasn't running anything. What are you talking about? Where's bullshit? Who has bullshit open? Fuck you. Okay. What is that mem copy? Mem copy comes from includes string, so we'll go ahead and include string. Strange noises. So we can do mem copy. Okay. What do we want to do? If PQ current is greater than or equal to PQ heap, that's the exact statement, that's the exact thing that we want to do. So if we are at capacity, so PQ represents the next one that we're going to put it into. And actually, now that I think about it, because PQ current is a UN32, so it is possible that this just completely overflows. So let's add another check. I think 2 billion should be enough. So we are restricted by limits of current. So if PQ current, or actually, this is going to be separate. If PQ current is equal to, well, peak current is like the next one we're going to put it into, right? Because, yeah, this is the first thing we do. When we get a new one, we first put it into, or we shift it into that current value. So if peak current is at the max, we need to just reject everything. Otherwise, it's going to overflow to 0, and that's not good. This is not a circular buffer. This is a heap. Very different. We cannot just loop back around. So if PQ current is equal to, we need a funny variable. Hold on. How do we get it? It's going to look like, where is it? Some dumb math I did. Can't include. Here. No, where is it? Where is it? Must have been here somewhere. There was like a double shift and a plus and a minus. Here. UINT max 32. This would be 64 or 32. So, and we're just going to do, it's going to start as a 32. We're going to shift it over by 31 bits. So this will get us something that looks That's going to be 1 followed by 31 zeros. And then we're going to subtract that by 1. That gets us 0 followed by 30 by 31s. Wait. Yeah, 1 followed by 31 zeros. And then we're going to subtract that by 1. That gets us 0 followed by 31 ones. And then we're going to shift it over by 1. That gets us 31 ones followed by a 0. And then we add 1, we have 32 ones, which is max uint 32. So if this is equal to the max 32, which is it likely? Are we going to have 4 billion events happening in the span of a single bucket? Maybe. We'll see. But we should definitely printf this because it'll indicate that we need to upgrade our infrastructure. So we'll need a IO, std IO, printf. Current has hit max value, upgrade to uint 64 now. That's it. That's all we need. And we will just return here. We're not going to do anything. Next up, but otherwise, if we hit capacity, so if we are greater than or equal to this, then we need to do a few things. What do? We need to reallocate something like uint64 type star heap is equal to malloc, not initial capacity. Let's just get capacity out real quick. Or we'll do this in here. uint64 type. So yeah, no, this is fine. Current capacity is equal to pq heap 0. I mean, we could also make it super. We could make it super explicit, like so. Via include pq.h. Index 0. Capacity index, capacity index, and then we can do malloc 2 times current capacity and capacity times size of uint64 type, which this is just 16 times the current capacity. Oh wait, no, this is fine. Okay, so we doubled. We'll call it doubled is equal to that. And because this cannot force us, because we're only going to push 1 at a time, this cannot force us to more than double it. This is not like the other case with the blob store. Anyways, listen to me drop some eggs in. 1, 2, 3, 4, 5, 6. Okay. Just keep that door closed. Too much laundry in there. Okay, cool. That was not difficult. So all we need to do is double it, and then we need to do that that funny mem copy again. So that's going to look like we're going to do a copy into doubled. We're going to copy all of the heap. We're going to copy the entire heap. And how much are we going to copy? We're going to copy current capacity. Yeah, that's actually a good call out. Else if we have the greater than, this can't happen. This can't happen because of exactly what we're about to do here. Current has exceeded capacity. It shouldn't. Please fix. Okay, so we're going to copy current capacity. So we're going to copy everything that's in the... oh, wait a minute. Wait a fucking minute. How does memcopy work? I think we might have a serious bug on our hands. Number of bytes to copy. Oh, hold up. Oh no. Wait, how did this even work in the first place? Wait, oh no. How many times are we doing memcopy? Oh fuck. Okay. MD capacity. This is metadata capacity, which needs to be multiplied by times size of BSM. How the fuck did this even work? I have no idea. Wait, is this gonna work? Okay, this is what the fuck is this? This is for store. Store does store in bytes. Yeah, because we're copying out. So yeah, so size is fine. This is in bytes. Store capacity, I think. Oh, this is store capacity. Yeah, this is bytes. Okay, so it's just this MD capacity. Only when we double this guy. Which is still concerning. How was this working without the investigate test? How the fuck could that have worked? That doesn't, like, it's bytes, right? Like this is bytes. Plus the number of bytes to copy. I don't get it. Yeah, like how do you use this? Yeah, size of S. Wait. Oh, countdown 7 minutes. No. Countdown 5 minutes.
5 minutes starting now.
I don't get it. Oh, that's C++. Oh, yeah. Yeah, memcopy in C. Number of bytes. Yeah, it's obvious. It has to be bytes. So how was this working? How could this have ever passed? Size of BSM. Well, what is size of BSM? What is size of BSM? This is blob store metadata. Cat include bs.h. Well, it's only it's 12. It's 12 bytes. So we were off by a factor of 12 here. Is it because we never actually tested it properly? Did we not like go all the way to 1024? Because, or maybe we only copied like the first few bits of it, and we didn't actually check. We didn't actually check some of the capacities at the end. I think we didn't so we only copied 1/12 of what we should have. Properly check the bytes at the end of bytes towards the end of the new metadata. This is definitely something that needs to be flagged, but good thing I caught that before it got worse. All right, so we copied the entire current capacity times size of UINT 64 type. So that's not current capacity bytes. That's 8 times current capacity bytes. So current capacity times 64 types. Okay. So we have memcopy. That's good. All we need to do now is we need to do doubled 0 2. Double it. Actually, to make it explicit, capacity index, and that's how we update our capacity. So current won't actually change. It was past the end, but the last one. So when we indexed the last one, it pushed current past the end, and previously would have just failed additional ones. But now current is still in the right spot. We don't need to change it. Heap has now been reheaped. Oh no, it hasn't. PQ heap is equal to doubled. Cool, that's it. So PQ doesn't change. Current. Oh, ooh, very important. Free PQ heap. Yeah, like that. Free my guy. Are we doing the other? Are we doing frees elsewhere? So every time we do a mem copy, we should have a free right after. We free the entire store. Okay. Where else? Yes, BS store is freed. This is metadata. Okay. Okay, so it looks like that's good. So this is all we need to do to make it double, and now this whole thing will work just fine. So cool. PQ is now doubled, but we found another scarier address in scarier bug in BS. So let's take a look at that. Get status. I don't think this should change any test, but let's see. Let's turn PQ and BS back on, just see what's going on here, and then we'll do VI tests, test PQ. Okay, how did we not see this? We must have. Okay, so it's all just one big beautiful test. Oh, we barely tested it. Wait, it was the. Oh, okay. Void test doubling. Make a new one. Fuck it. I'm actually gonna. Wait, this was metadata. There's a big bug with metadata. This I'm sure is. Hell, this might actually fail too. Never mind. Okay, VI test test BS. How did the fuck did we miss this? Should be a for loop somewhere. Yeah, right here. Overflow tests. Oh, right to the eggs. Shit. Okay. Got some pretzels. Delicious. What the fuck are you doing here? Okay. Damn you. Okay, what are we doing here? What's the goal here? Overflow tests. So this Okay. So at this point we get the 0 block and we're all good. A certain number is equal to 1023 because this is blob store. This is blob store metadata. Okay. Wait. What the fuck? Wait, how is that possible? Wait. No. We have double encode. This isn't gonna run because it's not because it's has compilation errors. If not defined PQ. Oh, hello. Okay. Did I mean the current capacity? Yes, you're goddamn right I did. Silly little errors there. Else if, oof, that's a hell of a bug there. Current capacity, no, it's right there. Oh, capacity, here we go. Current capacity, go ahead. Nice, okay. Assertion failed. B stores equal to 0 block. Why is that? What the fuck? Wait, if we modify metadata, we don't need to shift capacity. What the hell is going on? Wait, oh, this is PQ, ABS. No, shifting block, that was that blank to blank, and that's only happening once. And it's because first is greater than last offset, and there's no space between last and first. What the fuck? This shouldn't have changed anything. These tests should still be passing. And that's really annoying. Here. Hey, shoot. Okay, this is a bit more revealing. Shifting block, that was at 4096 to 0. Why would you do that? Wait. Overflow. Done. Okay, try those tests again. Oh yeah, I need them open on the same page. Okay, try again. Or okay, well this is a bit revealing actually. Okay, what were those errors? What were those errors? Tell me. Ah. These are all in scheduler. Doesn't really concern me as much. Hold on. So all within the overflow test, we got a bunch of crap going on here. Why is it if I reserve 1,000 it overflows? I don't get it. Well, we never got a... This fails. Sword did not get reallocated. Yeah, it shouldn't have. Why did it? Why would that do anything? Are you kidding me? This messed up this test. Is that it? Did we do something weird. Let's see. There. Just the metadata. If we run out of metadata, it's not necessarily the case that we need to redo it. Oh wait. This is a circular buffer and now it's full. Wait, how are we even hitting this possibility? We really shouldn't be hitting this possibility. If we double the capacity, then wait, let me rerun. Okay, now it passes. What the fuck? How? What is MD capacity exactly? Why does this fail? Hold on. So this is what should happen in the overflow test, but it fails. We now get a failed assertion for some reason. Because this causes an overflow somehow. Why? Wait, first offset, whoa, back up. First offset 496, last offset 492, last size 4, size 4. Yeah, that makes sense that it wouldn't fit, but wait a minute. Oh, so here, wait, what the fuck is going on here? First offset 496, last offset, last size 0. Huh? Wait, but man, what the hell? Oh, because we properly copied it over, now it doesn't want to work. Wait. No, this is right. BS start has to be at 0. Like within the metadata array, we are now at 0. Oh wait. The fuck was that? I don't get it. So what happened here exactly? Oh, maybe we do need to shift the data. Maybe it's not simple enough to just do this. Because what if you have... okay, what is this supposed to do exactly? Overflow, right? I think these tests these tests are more interesting. Last after first test. Because, oh wait, no, first, last before first, so it kind of like loops around. This one's a bit more interesting, I think. Oh, this is, what is this doing? Overflow test, right? Okay, look, I'm just trying to test the metadata, not the other stuff. This should work fine. Okay. What do we do? BS address equal to 0. From 0 to 1, 4, we reserve this many. So now both are at 0 because starts at 0, never change, and then MD is at 0. And then we get the 0 block. This frees up 1 to be at 1, and then we reserve one more, and then it'll be at 0. Actually, let me see where this is happening exactly. Printf start and end at 0, because I think we shouldn't be shifting here. We should not be shifting. Start and end at 1. But this is actually good to test out this scenario, because maybe it's a problem if it goes like start, finish, and we just chop that off. Yeah, it has to, wait, it might be, right? Let's see. Make test. Okay, so this is without the fix. No, we need with the fix. With the fix. Okay, so with the fix, here's what happens. Okay. Start and end at 0. Start and end at 1. Oh, sorry. Start at 1 and at 0. Okay, so it's the same one. But then as soon as we as soon as we do another reserve, that's when we hit capacity and we need to wait, what? First offset. Okay. Wait. All right, we reserve 1024, we get 1, and then we reserve 1. That should just put us back at that shouldn't mess us up. Wait. What? Wait. Okay, so we are definitely hitting this. Let's just print some things out. Let's see what this does. Do MD start, MD end, and kind of toss those guys in there. BS MD start, BS MD end. Okay, let's see what we got now. What? Oh, right. Just do these two then. And then return 0. Okay, maybe. Should we return 0 here? What's going on here? Okay. MD start. Wait, we don't even hit this. Well, wait, we hit this twice though. Oh yeah, because it's like that. Okay. So it's not... Wait. Oh. Oh, I think I need it here. This is the initial case. It's not the doubling of capacity case. Oops. Here. And then before and after, we kind of need this. There we go. Let's see it. Okay, so MD is at... Okay, start at 1, end at 0, and then MD start is 1, end at 0. And then immediately after we reserve, we have this scenario where we have MD start and MD end are at 1. Does that make sense? Does that make sense? Wait. Huh? Oh, I think it's this call actually. Okay, so MD start is equal to MD end. Make it more clear. Doubled now. D now. There. 38. What do we got? Okay, here we go. So MD start is at 1, MD end is at 1. So we have this like 1 all the way to the end back to 0. That's what it looks like. But then after we double it, we correctly set it to 0, and then we have the end at 1024. So now we can keep pushing past 1024. The only problem is we shifted the entire metadata over without a we shifted the whole metadata over, but now the start, which should be like the last, or like the first, kind of like the earliest thing in the bucket, is now 0, which is right after the last one, which should kind of be the, like, this is like start, like this 0 index was like the last thing that got indexed, and then end 1024 is like the second to last thing that got indexed. So we're trying to fit something in. This is weird. Yeah, so we basically have this math where it's like, okay, the first offset, so start 0, this is at 4096, okay? And then the last offset is at 4092, which, you know, because they're all size 4, this tracks because this is the last thing to get indexed, and this is the second last thing to get indexed. This is kind of weird because this can be possible. Like 4096 can be less, can be greater than the last, but only if we loop all the way around. What this? Oh god, this is weird. Why do we double here? 496 to 0. Wait, but then where does the 0 block go? Oh, the 0 block got freed. This doubling code, because we messed up first and start, we completely messed up the whole doubling code. So this actually needs to be a little bit more careful. We do actually need to shuffle it around a bit. So What is this gonna look like? So we can't just do mem copy here. We actually do need to be a little bit more careful in something like doubled of i's, something like, we're doubling metadata, so we need to do bs start plus I, but not just that. We actually need to do mod bs md capacity. So this will change everything, and also takes care of this little size thing. So doubled I is equal to bs metadata bs start plus I. So this will yeah, and then we can do this safely, okay? And then I'm gonna rerun it. You should see that this line specifically changes. It should be first offset 0, last offset 4096, and then the math then becomes much easier. And it's like, is there room between 4096? Oh wait. Wait a minute. Shit. This actually is a little bit weirder than I thought. If we can't do this. We can't do this. If we have like 1 all the way to the end and then back to 0 and then to 1 as our circular buffer, we can't just shift. Oh fuck, this is hairier. This is hairier than I thought. Hold on, I need to lay down and think about this. The reason we can't just shift values, and why I initially went with this whole thing, is because anyone that references the old values, like the old indexes into the metadata, which is the whole point, that's how we track references, they will lose their reference if we shift it. So what do we actually do? Oh, this is really hairy. We could have a translation table, I guess. Maybe. Maybe we copy the entire metadata as is, and then we just keep expanding. Yeah, wait. Oh, it's so weird, but okay. So if we take the metadata table, so it loops, it starts at 1, goes to the end, then loops back to 0, and then to 1. If we take everything before the finish, so just the 0 to 1, and we paste it on the end, we paste it into the new array. If we paste it into the new array, we'll basically have a copy of the data. So that metadata that was at index 0, so kind of like 1 before the finish, will now be at 0 and at like 0 plus the initial capacity, because we'll copy it into the new doubled thing. But we don't need to erase the data at 0 because someone will still be referencing it. And the question is, and then start remains where it was. Start remains exactly where it was, unchanged. So if it was at I guess 1, start would be at 1. It stays at 1. And then end gets a boost. End is shifted over which yeah, it's a bit weirder way to double it, but I think it actually might be a little bit more obvious to reason with. Now let me just, the only case I'm worried about is if we double the capacity and we just leave the data as it was, so we copy it in, but we pretty much ignore it. We pretend we're not tracking anything between 0 and start immediately after doubling. But we still, someone still holds a reference to that, oh fuck. Someone holds a reference to that last one, that 0 index. That 0 index links to a blob. Okay. This is really weird. I think we might be able to get away with some, maybe like some phantom indexes. Let me think. So if we go from 1 all the way to the capacity and back to 0 and then to 1, that means that the highest index is at, oh god, what, this is one hell of an issue, one hell of a riddle. Okay, so start and finish, in like the MD sense, they still have some very useful information in them. I'm trying to think of a way to do this without like reshuffling a bunch of references. Maybe some kind of like translation table. Like if you go into 1, like if you want to get what's at index 0, then you need to dereference it. You'll need to dereference it not just from 0, but also from a different place. But then eventually, fuck, this is really tough. This is the priority. No, this is the blob store. This is how many snapshots we need to keep in memory. You know what? There's an easier solution to all this. BS reserve, right? If BS is equal to MD, and here's what we do. MDS is looped back to MD end. We need to double the capacity. Yeah, this is very unfortunate, but I'm just gonna say I don't want to take up too much memory. There is no clean way to update to double the metadata capacity. If we just ignore the current values of MD start and MD end, we lose sight of, wait, unless, oh my god, okay. What if we, What if we prepended a... What if we prepended a... what if we prepended some, like, start value that copies the... But then that can never go away until... Oh, this is so weird. We lose good tracking on the store if we try to move move metadata 0 start to a new spot. We need to maintain 2 copies. If we, yeah, that's pretty much the 2 options. So we just don't. I mean, we could have a, ironically, this could actually take an initial capacity for MD, because different, yeah, you know what, that's not even a bad idea. Let's just do this. MD capacity is equal to whatever gets passed in. This is a UINT16 type. Wait, yes, a UINT16 type capacity, and we just do this. Done. Cool. So we do need to update the tests, but overflow is not going to be happening. We're just going to reject it, so we're going to do this. So we just don't. Return. Be sure to size capacity of your BS properly. Oh wait, no, that's well, store capacity is infinite. It can be doubled easily. That's not a problem because we can update the trackers in all the metadata pretty easily, but this is specifically metadata capacity. So right here. Yeah, okay. So yeah, 1024 is still fine. We need to update the bullshit header and BS, we'll call this UINT64 type metadata capacity. Okay, looks good. Oh wait, yeah, that's good. Okay. So this will probably make some tests fail, but nice. Conflicting types, where? No, it's right there. Nope. Oh, return. Yeah, no, we're not doing this. We're not doing any of that. Okay. All right. 20 and 32. Huh? I mean, oh, who's got the 64-bit? Oh, I see. Okay, try again. BS 50. Oh, what do you want? What do you want exactly? Initial metadata index. Get fucked. Whoa. Okay. Okay, let's fix that via the scheduler real quick. And this is on line 145. This is a, oh, you want an LLU? Fair enough. And 142 also wants an LLU. And line 15 does not take a capacity anymore. Or no, it does. No, this is priority queue. Never mind, this is something else. And slow bucket also doesn't need capacity. Cool. I'll go ahead and do that, and test PQ. All right, cool. Let's see what's up with test PQ. Test PQ. 18, we don't need, anyone that calls PQ in it is probably off. Nope. Okay, cool. Try again. Okay, so it's all in test BS, which is good. So let's see what's going on here. In test BS, we got 11. BS in it. Yeah, you do need a initial metadata, and I think 1024 should be 1024. So this is exactly how many types you can put into, how many blocks you can put in. After that, it's just going to reject it, and you're going to get a 0, or you're going to get an infinity when you try to, what am I saying? You're going to get a -1 max value when you try to do it. All right, let's see. Okay, cool. What's going on here? This is on line 71. Assert BS, assert number is equal to 1024. Because we were okay. So previously we were copying it, we were duplicating it, but then we were just discarding it. Like we were only copying 1/12 of it and calling it a day. So that was great. But this is even worse because this should be -1 actually. What do we call this? -1? Not -1. If you've included the header, you should be able to just do initial metadata index, which is basically like a fuck you to the you know what? Will blob store ever need more than that many objects? You know what? Initial metadata index. Well, maybe we'll bump it. We'll see. Yeah, these are all going to fail. Let me just go through all of them and fix them. We don't double MD anymore. BS, what is it? BS star is equal to 0. No, it's not going to change. It's not going to do anything actually. MD capacity is still going to be 1024. And it did not get reallocated either. Okay, looks good. Yeah, it didn't get, store didn't get reallocated. That's completely separate. Okay, cool. Let's go ahead and commit this. We got some bug fixes. Oh, one last thing I need is the free list. We'll get to that in a second. Okay, so first of all, the priority queue change. Wait, do they rely on each other? I have no idea. Git add include BS, source BS, test BS. Okay, git commit. Blob store fixes. Metadata is very difficult to is it though? Is it though? Everyone that has a reference to who is going to have a reference to the metadata? It's going to be in the response table update. If you want to pursue it, you'll have to update all references to the metadata, probably in response table. Okay, git status, get add dot, get status, get status, get restore staged. This is going to be, we're not going to commit test main, or same thing for source scheduler. Get status. All right, git commit. But what do we do with a priority queue? Priority queue we actually made much better because now we can upgrade. We can open read only. Initial capacity. Priority queue can now double. Nice. The other one we want to fix is a free list. So this one again, capacity is capacity is questionable. Yeah, fuck it. Let's make it double. Let's blow this guy up. Fixed size free list. Doesn't need to be fixed size. Maybe. Oh, by fixed size I mean this. This is the same size. So how is order actually used? Let me see. Order data, size of order, order. Okay, cool. So what we really need to pass into here is not capacity. It is whatever the type of this is. So what's the biggest thing that we might put into this? I don't know. We'll keep it small. UINT 8 type. Like object size. Sizing. We'll call it sizing. So mal capacity. Capacity. We'll want an initial capacity probably. So vi include freelist.h. We'll do. Damn it! I forgot again. What was it? Shut up. Shut up. Not you. Not you either. Here. Something like that. Okay, well, I'll paste that in. Set a const int, we'll call it initial capacity. This one could be higher. It's more chill, 8192. This is going to be a UINT 64 type. 32 should be fine. We're going to have a lot more than... Yeah, 4 billion should be enough for what I plan to do here, but we'll see. It might genuinely not be enough. Initial capacity 8192, and then we'll go back to free list. So we'll do initial capacity times that. So same thing here. Size of order. Now we're gonna do sizing. And this is not gonna be this is gonna be a void star. And anyone else that calls this is just hold on. It's just anything can go. You can just put whatever in here. Which is a funny way to say it. Why is this a void star now? No. Wait, I don't. Ooh. No, this is weird. Well, we got rid of order for the most part, or data. So not order anymore. We need to do data. And this is just ID. Turn ID. Any other mention of order? Yeah, just call this ID. It's pretty simple. Do we not return it? Huh. Okay, there's no more mention of order. It shouldn't even be in here, honestly. Okay, so if we insert, we need to pop an ID from the stack, and then we'll return that ID, but we also need to write the data to it, don't we? Which is, oh, do we have a pointer to data? That could work. That could work. Although we need a void star star, I believe. Because it's an array of voids, maybe. What a mess. Okay. Oh, we can't call it data. Oh no, we can call it data. Um, a little bit weird. Wait, no, this can't be it. No, this is right. This is what I want. But we need to like maybe do this. But why do we need an address to it? Can we just pass the? So when we insert, we're gonna make some data. We're gonna get a reference to that, and then we're gonna dereference it. Why can't we just pass in the data directly? I don't know. It's something like this. Really not sure. And this, we don't even need to like undo anything with the data. We just increment the stack. Now, if we insert, we keep insert, 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 and then suddenly the FL capacity. Oh my god. Okay, so there's an array, and there's a stack of indexes, and then all of a sudden the stack pointer is 0, meaning that the stack pointer is right above because we first decrement and then we get it. So if it's at 0, we're going to try to get -1, which is a problem. So here's what we do instead. We basically just need a fresh batch of indexes. So what we can do is go from capacity to capacity times 2 and just make a new stack. Ink3ink. So we're gonna do uint32 type doubled stack is equal to malloc 2 times initial capacity times size of uint32 type. All right, and all we need to do is go from 0 to capacity, and we'll do doubled stack. We'll call it yeah, I is fine, but we need to do I plus, or let's do this, capacity and capacity times 2, and that's it. Oh wait, no. Okay, we have to do this somewhere. We'll just do it here. Capacity. Okay. We can't do a mem copy because this is can't do mem copy because this is genuinely new data, new indices. And then we also need to do, we're not going to return, fuck off. uint30, sorry, void star doubled data is equal to malloc 2 times initial capacity. Okay, I'm gonna change the wording. It's not sizing, it's the type size. Okay, and this needs to be stored here because it's that important. It's gonna be void start data, and void order can fuck off, and then we need this is fixed, so uint8 type type size. Okay, and then we have fl. This could be const actually. Type size equal to type size. Type size. 610. I have 2 hours. Okay. Times fl type size. Cool. So that's a double data, and this one, this is an array of whatever, and that array is currently full. So we want to take that whole existing array and just copy it. So we do mem copy into double data. What are we going to copy? Data. FL data. And how much do we want? FL capacity. And then we double capacity. FL capacity doubled. if this somehow goes down, we got a big problem. I guess we should probably catch that, huh? Let's see what that would actually look like in Node, for example. X is equal to, what is initial capacity? 8192. 2. X 1. Just keep doing that a few times. I think it's a 32 type bit, and we have a 32 type bit anyways here. Oops, damn it. Oh, here we go. Oh. It's a uint, it's not going to do that, right? If it's 0, yeah, so it could be, quick check. If FL capacity 1 is equal to 0, printf, completely out of capacity. And this, wait, this would be a really big problem because, wait, we should do this first. Without capacity, re-architect, free list, because we need to be able to, I think we only need up to 25 bits, really, because 39 bits are taken up by priority elsewhere. And this is going to be a return. What is this? 32 type. Zero. No, 0 is actually a valid return. So if FL capacity shifted 1 is equal to 0, little hack there. This is basically a little trick there. Okay, whatever. Return some bogus. Okay, so if doubled, okay, let's say normal scenario, mem copy, we copy the entire capacity and we shift it. What else? What else can we do? Void double data malloc. Oh, right. FL data is equal to doubled data and free FL data. I think that should do it. Releasing cannot. Wait. Oh, we need to. Let's see. Stack. Oh, stack. Yes. I guess only if both succeed do we want to do this. So we do free FL stack, and then we do FL stack is equal to doubled stack. There you have it. So SP stack pointer, it's going to be initialized to probably the original capacity, because we're only going to insert capacity more. And by inserting capacity more, we double the actual capacity. I know I sound crazy, but FL SP is equal to capacity. Okay. This is exactly what we do here. Type size doesn't change. That's the whole point of it. Cool. So this looks good. Double data, doubled stack. Wait, not initial capacity. Good call. Good fucking call. Cool. So now we can double. Okay. SP, okay, and then once we're here, we just do it normally. We subtract SP, we get an ID, we assign data into that ID, and then we just return an ID. Wait, isn't this just going to be like 1 byte? I mean, oh, this is ugly. Also, the order is not going to work anymore. I don't fucking know. Something like that. Maybe. Let's see what happens. Right. We need to update the header. Oh, right there. There's no more order. No. There's only void star. And this is going to be called ID. And this is going to be called data. And I think that's it. Anything else? Yes. Conflicting types. FLU. Oh, yeah. Yeah. This is going to be type size. And actually, does C have parameterized type classes? No, that's not it. C, what is void star? Don't tell me. What the hell is no associated data type? Okay. Oh my god. Okay, go back to 14. We'll do FL capacity. Oh wait. We don't need to do an initial capacity. I want to see what happens if you dereference a void star type. Oh, you need a CD. Oh, talk to me. Okay, 66. Type void is not assignable. That's what I thought. Let's start with the other one. SP is equal to capacity, initial capacity, that is. And right here too. Cool, go. Only 5 errors left. Let's see what's up with 40. This is going to be FL capacity. And same thing here. Three errors, 47. Mem copy, you need string.h, believe it or not silly little string. FL sizing, no, there is not. It's called type size. Go. All right, let's okay. What is going on here? What is the trick? How do we... Wait a minute. One of these is... Yeah, okay, so this is where we write. Okay, and it does not like this at all. ISOC does not allow indirection on an operand of type void star. Incomplete type void is not assignable. What, you mean I can't just write generic bytes? Okay. What do I do? What do I do? Let me split these up into two lines and see what's going on here. What if I cast them to like a uint 8? What then? Okay. So these are does not allow indirection on an operand of type. Is it the plus or the star that you're unhappy with? It's the star. Okay. Yes, it is a void star, but can I do this instead, maybe? All right. Well, yes. That actually kind of works. I don't like this because we might be doing a lot of fucking inserts. And I guess it'll be up to the caller to know that. Oh my god. We need a. What are we even doing here? What are we going to be shoving into these things? This is so weird. Maybe it would have been cleaner with order. Maybe not. I don't know. What's wrong with you? Incomplete type void is not assignable. FL data. I mean, looks fine to me. Data. Yeah, I mean, I'm more confident about, but why? It's not assignable. Well, what the fuck am I supposed to do with this thing then? It's a void star data, which is just a. It's mallocked. It's definitely mallocked, so that's fine. That's not. We're not gonna get a seg fault, but what? ID plus one data. ID plus one plus I. All right. Let's just use the old Google. Don't look at that. Don't look at the AI generated. The void is not assignable. Oh my god. Oh, this is what this guy was talking about, huh? Wait, no. Wait, where's he? Okay, give me a second. I'm gonna get those eggs ready. Let's keep going. What was I doing? What was I doing? Oh, incomplete type void. Of course it's not. Why would it be? Why would it be assignable? Hmm. I mean, what if it was just a bunch of okay, this is kind of cheating, but instead of void data, oh, this is so weird, but uint 8 yeah 4 type data, technically like any or void start data, but easier this way. So that should be fine. And then okay, pray that that works. See what happens. Ooh. Assigning to uint8, aka unsigned char, from incompatible type void. Maybe we have like a, hold on. Maybe we have shared helper methods, but specific types of free lists use, what do they use? Fixed with like order or something. All right, fine. You don't want to be that. Here, how about that? You happy now? How's that? Oh my god. Unexpected name type. Okay, so all of a sudden you don't know what uint. So confused now. We have stdint. I don't know. uint8 type t. I don't get it. Data's right here. It's a void star. All you need to do is data I. Oh, is it data plus I? Whoops. Nope. What's so unexpected about this guy? It looks fine to me. Oh, is it uint star maybe? Is this it? Oh my god, finally. Oh yeah. Silly me. Silly me. How I should have known. Alright, now we get a million errors. Mostly in the test, I see. Alright, let's see. A redefinition of initial capacity. For fuck's sake. Okay, fine. I gotta update both references. Hold on. Call it FL initial. There you go. Anyone else use it? Init. IFL underscore. Okay, that's just ugly. Okay. Happy now? "12 errors. Mostly in test FL." Okay, cool. All in test FL. Yeah, we updated it a bit, didn't we? Test FL. You can just drop the whole order thing. Oh boy. Actually, this is going to be a bit more interesting to test out now, since we have the whole... This is going to be interesting, because we completely changed the plot. Start with the bottom. 11. FL init 1024. You want a uint 8. 4. How's that? 12 errors. That was just a warning. Okay. What's wrong with the 39? Yeah, you're not going to be a type. You're going to be something like that, maybe. Wait. Oh my god. Yeah, we definitely need a... I don't even know how the fuck we're gonna do this. Yeah, I really think it might be easier to do it with a type, but we'll get to that. The best we can verify is something like... Let's do UINT 64 type. This is gonna be like the full number. We'll call this... This is what we're going to be putting into the data. Could actually be anything. So 1 times 256 plus 2 times... I think I'm doing this right. 3 plus 4, right? I don't know, is equal to... There. Okay, so we don't need that anymore. Just ID, it doesn't have to be. Insert FL, we'll insert, I don't know. So we're gonna take all those 4 bits and we're gonna insert them. And then what we're gonna do is we're gonna try to get that thing out. So we're basically gonna do this exact same thing, except something like this. It's mad ugly, but 2, 3, 4, 4, 10, 1, 2, 3. Is it 4? Yes. This is doing the same exact thing. And order type is equal to 5. I don't know what this matters. Oh. We'll change that to a 5, I guess. Whatever. And then we'll insert again. I don't know. And then we're gonna assert that this times 4 plus 3 is equal to 5. Yeah, and then we release, and then we try to insert again, and we assert that the that's 1023. Does that make sense? Why would it be 1023? I think we need some more assertions here. Hold on. Assert ID is equal to 1024, and then 1023, and then pop, and then back to 102. Wait, how does that make sense? Oh, the first one is 1023, then 1022, and then 1023 again. Okay. And again, we have that 5. I'm just already 3 times 4 plus 3. What a mess, huh? Let's see it. All right, down to 8 errors. What's up? Incompatible to type of void star. Passing argument to data here. Well, no, actually, oh, it's not order ID. There's no order. Just, if you see order, just 6x. There. Down to 3 errors, cool. And again, it's with that fucking void star. I don't know, what do you want? Okay, here's what I can do this. Check this out. Void star ref is equal to this. Happy now? You fucking happy? You happy now? Ref. We can even do ref 3 is equal to 5. Or something like this. I don't know. Maybe it's like ref plus 3. Like that. Okay, and then we can do ref and ref. How do you like that? Okay, beautiful. Of course you don't. Why would you? Type void is unassignable. What if it wasn't a void? Just what if? What if it was a UINT8 type star? Yay, okay, cool. Oh wait, we're probably not even testing it, so test main. Test main. Let's go ahead and test FL out of everything and not anything else. Let's see what happens. Seg fault. No, but a failure. Line 18, what's up? 1023, why is it not 1023? What is it? What are we returning here? Oh, because initial capacity is 8192, it should be 8191. 8191, this is 819, this one's 8191, and this one's 8190. Okay, 3, 2, 1. Okay, still failed. Okay, the very first one failed. That is not good. Why would that not work? Why would that not work? Because we didn't insert it at the right place, because now we're doing void stars, that's why. So, in the data, I got time. I have a little bit of time. What is it? Thursday, so 8:30. Yeah, 8:30. Okay. When we insert, it's not as simple as just doing this. It's actually going to be FL data ID times FL type size. Type size is equal to that. Do we need to do this here? This is a stack. Stack is different. We do okay. So this is how we copy the data, and this is just raw data. We can just do that. There. And then we have this double data, and then we have we do a manual copy of double stack. Double stack gets this. Yeah, this is weird, but maybe it'll pass now. Still no. Okay, well that's kind of rude. Same line too. Did not appreciate that. Maybe we make it explicit. Maybe something like that. No. ID times 4. No, this should work. This is fine. FL data, is it like big endian or something? What is it actually equal to? Or little endian? Oh god, is it little endian? No way. Oh god, that was it. It actually is. Does that make sense though? I have no idea. Maybe? I don't like that. I didn't realize we were on a big Indian machine. Whatever. Let's do line 30. Did not like that. Why not? Why was the ID not 8190? What else would it be? What else could it possibly be? We can't go up. Can you give me a printout of FL, please, of ID? Printf ID is ID. Oh, it's ID2. That's why. Watch this. Nice. Cool. All right. Well, it's ugly, but it works. All right. We'll double it. For int I is equal to 0, I is less than, initial capacity is what, 8192? Initial capacity. Well, we already have one inserted, so we don't need to do that exactly. No, we have release, insert. Okay, yeah, so we have just that one. We'll do, I don't even care. ID is equal to FL insert. We'll just do the same ref. And then we should at least see, I'm just going to directly put this in just so we can see it. If FL is equal to 0, print, we can do this by capacity actually. We'll do assert FL capacity is equal to 192 times 2. Well, failed. Okay, probably because we need to do one more. Last one, so we insert it one last time. Nice. So that must have shifted everything over. Cool. Laying down for a second. Okay. All right. So FL is doubling. Oh shit. FL is doubling capacity. Let's go ahead and do this. Include source FL and tests tests FL. Commit free list can now double in size. Okay. I'm so sleepy. So damn sleepy. Actually, could use some Gert right now. I love me some good old Gert. A little bit of matcha in it. Nah, next time. Love this stuff. Actually, I don't even need this cup. See it straight from the container. Love this shit. Actually, we got some vitamin D. I'm just gonna start wiring this whole thing up and see if what else we need. Off the top of my head, I don't know, something. Okay, let's talk. What do we change in the scheduler? Oh, yeah, that's important. Git add source, git commit updates, updates PQ references. All right, let's actually look at main now. Okay, we have a scheduler, we have this. We are now, I think, kind of ready. We're definitely going to need a few more files at least, but I think it looks pretty good. Or was there a bug? Let me check the scheduler real quick. Did I have any notes? Oh, right, we wanted to directly test the scheduler. Don't think I forgot about testing. Come on. Test scheduler, my favorites. Make test. What do you got for me? Talk to me. All right, cool. Let me see. What do we want to do here? Schedule fast. I mean, it's kind of dumb. We don't always know that we're gonna schedule fast. It's gonna save us some bytes. Let's get rid of the fast prefix, suffix. This is my magnum opus. The where is it? Oh, there's two of them. Okay, good. Make test. Nice. Cool. What can we do with this? What can we do with this? We pop it. I kind of want to do a. I'm gonna do this. Raw, priority, type shit, and params. And now we're gonna have a bunch of crap in here. Scheduled e bits, so like event bits. Type is gonna be I hope this works. T-mask. Do we have T-mask? Fine, I'll add it. Oh, wait, no. Wait, yes. What the hell is a negative number? Never heard of it. Params. Params is just... it's going to be confused with priority, so I'll explicitly call it static const uint8 type param mask is equal to 1 if we have 64 bits. Wait, it can't be an 8, can it? Oh, but it can. Oh, this might be weird, but 64 minus the priority bits minus the type bits, that leaves us with something, and we want to do 1 shifted over by that, right? And then minus 1. $64 is this magic number. Yeah, 64 is a pretty magic number, isn't it? What do we even want to call this? Like entry? Not entry, maybe thing? Thing size? A full size is equal to the size of uint64 type. Oh wait, this is 8. 8. Yeah, and full size is right here. A full size bits. Full size bits. And right, there's a lot of math in here, and all of it is necessary. Full size bits. So you have the param mask and param mask. Cool. So that should allow us to... the fuck? Here. There. Run it. Whoa. Nice. What's wrong with you? Oh, there. Oh, no. There and there. How's that? No, doesn't like it. Is not happy. Why not? Full size bits. Oh. Yeah, you're not. Nothing's gonna compile now. uint8 type. Go. Size of. What is N1? Where did I get N1 from? There. Go. All right, enough of these silly remarks. Like, shut the fuck up. Well, it works, doesn't it? Whoa. What is params? Why is it 232? I did something wrong. Should be 1,000. Because this is off, isn't it? Probably. Conversion from int to uint8. Oh, this can't be. Wait, why is it? No, this is not. A mask can't be it could be a be a 32 maybe, but then that limits us a bit, but whatever. Wow. That is beautiful. Let me void log full, and we'll take a UINT64 type. This thing is probably gonna be pushed somewhere else, but we're just gonna take this thing and run with it. Okay, cool. I'll just do log full scheduled. All right. Should we have a peak? Should we do a scheduler peak? Or would that be too complex? Maybe. We'll see. Shit. I should head over soon. Let me. Okay. Oh, do we still get errors? Make test. Yes. Right. It's not scheduled. It's called raw. There. Cool. Wow, that is beautiful. That is beautiful. So we're gonna be doing a lot of bit shifting, if you can't tell. So I just realized that if we're in the scheduler, and even if we don't have slow bucket. Where's slow bucket? If it's not empty, what if it is empty? What if it is empty? What do we do? We're done rescheduling the slow events, but there could be another slow event coming, and we need to be ready for that. We don't need to reschedule anything. Oh, just, yeah, here we go. It's just reschedule the slow checker. So, I believe, if we just do this again, or we can call it something like next. There we go, next. If we just do next is equal to this and we log full, I just want to see what happens. Let's see what we got here. Priority is 0. Oh shit. Why? Did it not get rescheduled? Wait. If we pop it and we have that 7 type event and we log full, let me look into scheduler a bit. It should have been relogged. Printf. Well, what's going on here? So we clearly popped another type 7, but the priority was off. Did we not create it properly? We didn't reschedule it properly. So priority is 0 for some reason. I wonder why that is. Where we reinserted is right here. No. Just reschedule the slow scheduler. It's once an hour, so the cost is minimal. Priority is like time, but why does that mean max delta is 0? Maybe. Schedule is just the object, so we just need next LOU and max D LOU. Next max delta. What is next? Next is gonna be that interesting one. Max delta is gonna be It's a lot. So why? Now set to 0. That can't be right. Max delta set to 0. And this looks fine. That 1000 stays because we reschedule it, but something's not right here. Max delta. I guess this max delta just gets ignored somehow. Let's take a look at this guy. Why is this the case? Max delta p span delta -1. Could we? Now set to 100, which is fine. Checking PQ number 0. Wait. Is empty. Checking PQ number is empty. But let me do this. Yeah. Let me make this a bit more clear. Okay, this looks right because we have 8 buckets, right? So 7 must not be empty. 7 must not be empty because we scheduled it in the previous one. And then we pop out. What do we pop out exactly? Let's do printf raw pop LLU next. Talk to me. Raw pop is this, which is way lower than this, which tells me that we didn't properly schedule it for some reason. It wasn't properly scheduled when we rescheduled it here. So next, this guy. So when we called it back again, why did this not schedule properly? Did we schedule something else? I mean, this looks right to me, but let me do this. Schedule invoked. Fuck. Maybe it's this thing. Well, no, it clearly gets rescheduled. It just gets completely butchered. So schedule invoked. Wait, schedule invoked, and then we reschedule it. Then we schedule it. Wait. Okay, so we schedule it normally. No, we schedule it normally here. And then we pop it, which then schedules the next one. But then returns the other one. And then this is the next pop. So something in here is wrong. So, we're not scheduling it properly in this other one. So let's see schedule invoked. Why is delta nanoseconds just being ignored basically? Resulting bucket is correct. We definitely calculate this correctly, but then it just, right here, this is the scheduled event. About to push event. Scheduled event. Okay, let's try this. So we have a schedule, we push, and then we pop, which then does this, which then reschedules it, and then we have this tiny little event being pushed into there. Now, why would this be the case? Why would this be the case? Now, the sum... wait. Max D. Wait. Huh. What the fuck? Sum looks correct. Resulting bucket is correct. It's sum and ebits. Why would that be the case? Ebits is this should be like a what the fuck is going on? Shifted sum is still a big number, but then somewhere in between we lose that. Is it the or somehow? Like, literally, it goes from... Wait a minute. Okay, so we go from... let me remove something from the test just to keep it simple. We're just going to do this. We're not going to do the other one, okay? So let me rerun this. So, okay. We only pop once, and that pop causes a reset. Bingo. Why is it 0? Why the fuck is it 0? Huh? So shifted sum being 0. So this sum needs to be broken up into like the bucket, which this makes a lot of sense. Like this is clean. This is clean. We have 3 p bits, so wait, no, we have 39 p bits. So whatever this big number is, we chop off the bottom 39, and then whatever's left, that's going to be what bucket we land in. And this has to fit into our range, and we make sure of it like this. So this is 0 to 7. Now the question is, why does this not want to play? What is wrong with ebits? Ebits is full size bits minus p bits, which, I swear to God, if that 64 thing changed it, talk to me. Nope, shifted sum is still 0. Same thing. Same exact thing. Okay, it's not that. Is it because it's a 8? Can you not handle 39? Is that a problem? What if we did this? Talk to me. Shifted sum is still 0. Are you ever not 0? What if I just shift by 1? I mean, it should be a big number, but it shouldn't be 0. Like, what are you talking about? What's the limit? Oh. Oh, wait a minute. Wait. It works out to be exactly 0. It just happens to be, right? Because shifted sum is I don't get it. Well, if you shift it down by 39, then you get that 7 number, right? You get that 7 number, and then the rest of it is... Wait, is this just like 7? I'm so confused. This is just 7 times... It's just this, isn't it? Which makes sense, but it's kind of annoying. No, not quite. Okay, someone... Okay. Fuck. Okay, let me think about this. Oh, I think we might need to change how we set now and oh, fucking A. Yeah, we need to first we need to set now and then we reschedule the thing, because otherwise we don't yeah. Let me just do this. This, because we set it to 0 and then it needs to be 0, so I think this should work. Let's see. Wait, we need this shifted. Damn it. I think it's all these ones that we're using. They're just causing problems, you know? Here, let me just do this real quick. No, you're not a problem. You're not a problem. It's only if you have a big mask. Okay, try this. Oh my god, it's still fucking 0. I don't get it. What is e-bits, dude? What is e-bits even about? I don't understand. We can get much higher values. Sum is this. Now. Wait, but we're setting now here, so now should... Oh. Well, that changed something. Okay. Sum is, yeah, that's exactly what I want. Okay, so max D, but then shift it over. That's exactly the delta. Wait, is it? Sum is, what is this? I'm so confused. I'm still so confused. What is E-bits? Why is this not working? Does it have to do with the fact that this is a UN64? You know, fuck it. Just make them all UN64s. We're not gonna mess around with this. How's that? Does that do anything? Shifted sum still seems ridiculous. This can't be right. Oh wait. This is used to compute both the bucket and the priority. To binary. I think we might have fixed it, but I'm not super confident. Let's just see what we get here. Wait, segmentation fault? Oh, that was something else. Never mind. Raw. Here we go. Priority 100, type 7, parameters 1000. Priority 100, type 7, parameters 1000. Which, because its priority is 100, but we get from a different bucket, that means that we actually are like maximizing how far we can push it out. Okay. Okay. But I have no idea, because shifted sum is this weird ass number. And then what do we do with this number exactly? Shifted sum is E bits, so this is like the top 39 bits. Oh wait, 32 digits. Okay, so this is 32. This is 32 digits? Huh? E bits is what? 25. So 1, 2, 3, 4, 5, 6, 7. This is priority. This is priority. Oh, okay. Cool. Okay, so this is actually yeah, so we do some crazy math here. We add this to 100, but then when you take this number and you shift it so far that the top bits, the top ones fall off, you're just left with 100 times 10 to 2 to the power of something, which is exactly how we're representing this part of the priority. So yeah, I think that's good, but we definitely do want to, when we pop one of those 7 events, we want to set the now and then reschedule it. Otherwise, we sum based on the last event, which could be anywhere. And it's not going to be as far out as we could push it. Okay, I'm pretty happy with that. I definitely want to test this out a bit more with something like, I don't know. Let's try this. Schedule such what is it, 100 even? What are these again? Events is shit. We could do another event. We could do like a type 6 event, and the parameters will be 1, 2, 3, 4. And then we can do scheduler event 2, and let's make it funny. So this is the max delta, right? What was that? This is max delta. What if we just did? I'm gonna doctor this number a little bit. 4. Yeah, that should be good enough. Cool. And then this is going to be going into the slow scheduler, and it might break everything, but who knows? Let's find out. Delta too high. Oh no. All right, we'll get with that later. And that's it.